So in this video, I would like to show you what you can use some of the uAim systems for, and also what is being delivered in the package. And that's why I'm starting with this example game project here, where I place this turret that is from uAim. It's included in the project, but I added some custom logic to it. So this is not exactly that. So I copied this into the project, somewhere in my project, somewhere here, there. And then I added some custom logic to it to make this behavior that I'm going to show you in this example project. So some enemies are coming from there, and you will see how this will react to it. So as you saw, it finds or it tracks the enemies for visibility, and if it's visible, it starts applying its logic to them. So let's have a look what I did there. Just shortly, I just added some logic here, the loop, where, so this is from uAim, it derives from uAim, and I just added this loop here where I've searched for a good target every 1 second. And then I start the behavior if I have a target, and if I have no target, I stop the behavior. And that's basically the loop. And here's an event that is fired by the projectile. This is an interface that is being called by the projectile. It's also a custom projectile that derives from a uAim projectile, which is the uAim projectile is also in the project. I'm going to show you that as well. And then it forwards all this logic to the player, because the player can handle hits on other enemies. It can apply real damage and everything to them. That's why I just forwarded. So very short script overall. And this is also a function from my game state, which is a little bit more performant to acquire the list of enemies that are spawned. So that's how you, or what you can use it for. And now let's go to the demo map. Let's scroll down. So here's all the uAim content. It's a plugin, and if it's installed, it's in your plugins folder. You have to go to edit plugins and enable it to use it. So let's go into the uAim map. So this content here is all included, and the turrets here react based on this trigger. So if I walk inside this trigger, the turret shoots at the player. That's the logic that is included, like this. And before I show you some other features that you can do with the uAim, let's first open a blueprint. Or maybe I show the feature first and then I explain it to you. So here on the character, I'm also using uAim for targeting. So I'm targeting this object here now. And there's also an option to have this offset, which can be used in action-based games to have it offsetted. That's pretty cool to have. And there's also a logic where you can change the targets with the mouse, but this is just on top of everything. It's what you can use uAim for example. So let's have a look at the character controller that is included here. Where is it? Not demo blueprint. This character controller. So what actually is uAim? uAim, here it is. It's a component that you can add from your menu. And this component is a C++ component that has a lot of functionality. And the simplest functionality that it has, that is being used here on the player character. So here's a button event, which is called lock on. If this is executed, and if I have already a lock on target, if I have some lock on, if I've pressed this button before, I stop the auto lock on, and Otherwise, if I have no auto lock on, I search here for some target, and then I start the auto lock on using this target. This is a function from uAim, this is a function from uAim, and this is a logic in this blueprint here. And I think from this here, there's also a C++ implementation that I added as a helper function to uAim, but in general, you write these things yourself. That's your game logic, you know, you have your own targets, you have your own systems, and you want to do the stuff when you want to do it. And this is the auto functionality, but uAim also has an option where you just acquire the correct rotation and then you can apply it yourself. You can use the non-auto lock-on, for example, for writing some aim assist or something like that. I've done this in another game that I'm not showing here, but this is what you can use it for as well. There are also some other tutorials where these things are being explained a little bit in more depth. So here I just wanted to show you what it actually is. It's a component and how easy you can use it to have a lock-on feature on your character. So let's have a look at the turret now. Or, yeah, let's have a look at the turret next. So this turret is included, everything empty, because here's only the mesh added, and some parameters are set up, because the real thing is here. It's an empty object, which has here some scene objects, and it has also the uAim component. And in here, uAim is being used as well for the turret behavior. So in this start behavior, this you can ignore. We check if you have a target and so on. And then we say init custom auto lock on. Because on the player, where's the player? Here on the player, you don't need this init function because uAim automatically recognizes that this is a character. Derives from parent class character, so it knows it has this camera, boom arm, and everything it needs to do this feature here automatically without an init function. But in here, it's a custom setup with your pitch and an aim arm, and therefore you need to init it. You need to init the yaw, the pitch, and the aim arm. And actually, you can also set up the same object for pitch and yaw. They don't have to be different components. They can be the same as well. It will also work. So after initializing it, you start it. And then here's the logic to configure everything as needed for this thing to be a turret. So this logic is all in Blueprint, or not all in Blueprint. That's not correct. This is all in uAim actually. These are all uAim settings because there's a lot of things going on here. So there's interpolation method. You want a constant interpolation on a turret system. Then you have this yaw clamping, pitch clamping, in case you want to clamp it so that it can't go over these values. It can't rotate over these constraint values. And then there's also this prediction system where the movement of the target is being predicted. Look, if we are here, and this turret tries to shoot at the target, and the projectiles are slow, or they have some specific velocity. They need some time to reach the target, right? So depending on their speed, it can take longer or less long. And if it takes a little bit longer and the character moves, you're always going to shoot at the previous position of your target that you are shooting at, and not where your target currently is, which means the turrets have to do some prediction to be able to hit the target. And this is the second system actually that uAim comes with. So it comes with this target thing system, and it comes with this prediction system. And this prediction system uses the position of the target, it uses the velocity of the target and the acceleration of the target to compute a physically correct next position where it is going to shoot at to hit the target. So it tries to achieve all of that in an iterative physical way, and that's how the solver works for this prediction. That's the second system that comes with uAim. And here we set some prediction parameters to make it behave as we want. So that's the prediction system. So what we have right now, we have uAim, which is the component, and uAim comes with features like lock-on system for player and for turrets, and it comes with a prediction system that can be used on turrets to predict where the object is going to be, the target is going to be, and shoot at the predicted position. Then uAim has this projectile system, which means this turret shoots projectiles. And these projectiles, we can have a look at them as well. Let's open it up. So that's a projectile here, where we called some launch function and some stuff happens. So you get this projectile, right? You got all this logic, it's included in the package. So you don't have to write it yourself. You can just derive from this class and add your own stuff on top, which is what I did as well in the previous game that I showed you. So why do we need this projectile? We don't really need it, but you can use it, which means, I mean, in the sample, we need it to make the sample work. You yourself may need it. You don't necessarily need it. You can do it the way you want, but it's still nice to have something like that, because this is a system where this projectile moves physically, but it doesn't really collide, but uses, in this tick function, it uses some logic where it uses previous positions to not skip objects if they move, if you move, as if the projectile moves and if the target moves that you shoot at and you want to trace it, if you hit it or not, you need some logic for it to work in a solid and robust way. And this is this solid and robust way where it's going to have correct tracing, and it fires an on-hit event. And on this on-hit event that we have here, you can override it, for example, like I did in this sample from before. And on the on-hit, I added some other logic on top. So you can do this as well. You don't have to take this whole thing here. You can derive from this, write your own on-hit, call the parent on-hit, and do all of this stuff and do your own stuff on top, because you're going to get this hit result, and with that you can do everything you need. And yes, so let's try to sum it up. So it comes with a lock-on. So uAim comes with a lock-on system. uAim comes with a prediction system. uAim comes with these projectiles. And uAim comes with samples. So all this stuff that you see here is included, which also includes homing projectiles. So what are homing projectiles? Let's open the homing projectiles. So these homing projectiles, they inherit from the normal projectiles that I just showed you. And in the launch, they have their own launch function, which calls this simple function from the base class. And they are homing because they have their own lock-on component. So they have also a uAim component on top of them, and they use uAim to apply some logic in the tick function to make this projectile homing, to target the target. So they follow basically the target, and they do this physically. They do this physically correct, and they also use prediction. So this is also set up here. You can use it directly. And if you want a homing projectile with custom logic, you can just derive from this class and do your stuff. So this is also included in the package. So there's a lot of stuff going on here that is included, and you have everything here in your projects. You have the demo, you have the map. In the maps, you can just open it and check out the stuff that is added here. There are moving objects with tanks where this thing here points at targets and shoots at them. You can check out also before you buy, you can check out all this content in the downloadable demo that is on the store page. And yeah, that's a lot of things that you can do here. By the way, this is a rocket launcher that launches these homing missiles. And these other systems are normal turret systems. And yeah, you can use this in your game. Like, for example, how I used it in the one example that I showed it, and where I added additional logic on top of the logic that comes with uAim. So it's very easy to extend, and it's easy to integrate in your own stuff. And I hope this video helps you understand it in a better way, what's included and what's not included with uAim. Because yeah, it's very confusing, I think, at first if you look at the videos and everything. So yeah, thank you very much.